Hello everyone, welcome to Code Crafters Lab. So today we are going to see the second problem from basic hashing, that is finding the second highest occurring element in an array. Okay, so before moving forward, so please subscribe to our channel. So we are coming up with the entire TUF series here. So let's start with the video. So here we are given with an array of n integers and we want to find the second most frequent element in it. If there are multiple elements that appear a maximum number of times, find the smallest of them, similar to the previous example where let's say 3 is occurring 2 times, which is the highest, and 2 is also occurring 2 times in the array, which is the highest. So we will go with the returning 2 because it is the smallest number from the array. And if second most frequent element does not exist, then we have to return -1. Okay, and here we can see 1 2 2 3 3 3. So 3 3 is the occurring the most number of time, that is 3. Then 2 is occurring 2 times, so that's why 2, and 1 is occurring only once, so we are returning 2. Similar way here 10 9 7 7. So 7 7 occurring 2 times, so that is the maximum count. Then 9 and 10 occurring each once, but 9 is smallest, so we'll return 9. So yeah, we are able to give the correct answer. So let's try to understand this. So let's consider there is a array nums. Okay, and nums will be having 1 2 2 then 3 3 3 3 and 2. Okay, so visually we can know what is the answer here. 3 is occurring 2 times, so we want to return 3, right? So let's try to write a pseudocode for this. So what we will take, we will have similar way max count will be there, max count which will be 0. Then max element, right, that is -1. Then we'll have second max count which is 0. Then second max element which will be -1, and we'll be having one visited array. So visited array, and what's the size? Maybe n or 10 raised to 4, we know, right? 10 raised to 4 plus 1, so that can be the size. So we know the maximum element, that is 3 plus 1, that can be your visited array size. So here 0 1 2 3, so that is like a 4, correct? So we'll initialize it as 0 0 0. Okay, once visited we can mark it as 1, and we'll have one element name as count, which will be 0 initially. So what we'll do, we'll loop through the entire array. I equal to 0, I is less than n, I plus plus. Okay, so what we'll be doing, we'll be going one by one. Then what we are doing, we are finding its number of occurrences, right? Similarly in the earlier example where we wanted to find the highest, we were doing the same. So what we need to do, so let's say at the 1. Okay, so I'll like the search through the entire array, and I know that the count is only 1, so my count will become 1 here. Okay, and we'll see whether 1 is greater than max count. Yes, our max count we will update, we'll make it as 1, we'll update our max element as 1, right? And whatever here will get shifted to second max count, and it is same. So 0 from max count will go here, and -1 from max element will go here. Okay, so same way, like if you take one example, if you have 100 rupees, okay, someone give you that is like a highest rupees that you have with you. If someone give you 500, it will become the highest rupees you have, right? And if let's say someone give you 300, so right now second highest is 100. If someone give you 300, then second highest will become 300, not 100, right? So same intuition is here. So what we'll do, if everything is like the number occurrences is greater, then we'll replace the max count and max element, and whatever like containing in the max count max element, we will shift it to the second max count and second max element. And if let's say the count is not greater than max count, then what we'll do, we'll compare it with second max count. If it is greater than second max count, we will replace only second max count and second max element. Okay, so one is done. And also what we'll do, it is not visited, right? We will mark it as visited. Okay, then we'll move to second element 2. We'll search through the array, and it is like it is occurring 3 times. Okay, so our count will be 0 initially. It will become 3. So 2 is occurring 3 times. So we'll compare, count is greater than max count, yes. Then we will first shift max count to second max count. So second max count become 1, and second max element will become 1, and here it will get replaced with 3. Sorry, our count is 3. 2 is occurring 3 times, and max element is 2, right? And 2 will be visited, right? And again count will be initialized to 0. Okay, then again what we'll do, we'll go to next element 2, but it is visited, we'll skip it. Then 3, it is not visited, so we'll mark it as visited and we'll count it. So it is occurring 2 times, right? So count will be 2. So is it greater than max count 3? No, it is not. Then we'll compare it with the second max count. Is it greater than second max count? Yes, it is greater than second max count. So we'll only replace second max count to 2 and second max element as 3. Okay, then again we'll go to next element 3. It is already visited. 2, it is already visited. So we can return second max element, that is nothing but 3. So this is how we want to solve this particular example. So first array, to just go through like the entire array, iterate through it. Then we'll need one more for loop, right? For j equal to 0, j is less than n, j plus plus, you can make it as j equal to I also. Okay, then here what we'll do, if visited of I, it is true, then we want to do, we want to just continue, right? We will continue the loop. Earlier we did the same, right? We just have to continue the loop in case it is already visited. We have skipped, right? But if it is not visited, what we are doing, we are searching through entire array again from 0, right? So what we'll do, if, then what we want to do inside, like in the second loop, we will compare, right? What we'll compare, if we'll compare if nums of I equal to nums of j, if it is matching element, right? If it is matching element, what we'll do, we will initialize one count variable here, int count equal to 0, right? So what we'll do, we'll increase the count plus plus, and visited of j will mark it as true, right? Then after this we'll have one count in our hand, right? Then what we want to do, we want to compare if count is greater than max ent, right? That's what we want to compare here. If it is greater, what we need to do, we want to first like swap the elements from max count to second max count. So what we'll do, second max count equal to max count, and second, what is the variable name, second max element equal to max element. So we have shifted the maximum to the second maximum, and now we want to shift the count. So count will go into max count, right? And nums of I will go into max element, right? So this is the first scenario. Then the second scenario is count and max count are similar. Okay, if count equal to max count. So in that case, what we need to do, if both are similar, we want to find the smallest among them. So we, in that case, we only we don't have to update the count element here. We have to only update the element, max element equal to minimum of max dot min, maybe minimum of max element or nums of I. So whatever is the minimum, we will add it into the max element. So this is like a second condition we have seen in last lecture also. We want to cater that particular condition where both the count are similar for the numbers, and we want to then return the smallest number amongst them in the array, right? So that we have handled. So sorry, we have to do here else if, not only if. So else if, so here again we will need one more else if, right? So handle the second max element condition. So else if count is greater than second max count, right? Second max count is the variable name, second max count. Then in that case, what we will do, we will do second max count equal to count and second max element equal to nums of I, right? After that, one more condition, else if count is equal to second max count. So in that case, what we'll do, we'll only replace the second max element, right? And what we'll do, minimum, right? Not minimum of second max element or nums of I, whatever is the minimum, right? So this is how we have completed our code. And if we talk about the time complexity, it is O of n square, because we are using two for loops here. And space complexity is nothing but O of n, because we are using only visited array, and in the worst case it will have like all the numbers, so it is O of n. So let's try to code this now. So at first, what we'll do, we will take int max count equal to 0, right? Then int max element equal to -1, right? Then int second max count equal to 0, and int second max element equal to -1. Okay, these four elements are needed. Then we'll take one int n equal to nums dot length, right? After that, what we'll do, we'll just run our for loop, int I equal to 0, I is less than n, I plus plus. Then if visited, yes, we have to declare our visited array also, right? Boolean visited equal to new boolean of n, right? If visited of I, then just continue, right? Then after that, what we'll do, we'll write our int count equal to 0, and after that for int j equal to 0 to iterate through the loop, inside loop this is, right? And j plus plus. After that, if nums of I is equal to nums of j. So we are scanning through the entire array now to find the matching elements and increase the count. What we'll do, count plus plus and visited of j equal to true, right? So visited will be updated here. And once that is done, then we can close this loop here, and then we have to just do our condition. If count is greater than max count, we have to update four things. Replace all the maximum count and maximum element to second max count. Second max count equal to max count, right? Then second max element equal to max element, right? Then max count equal to count, and max element equal to nums of I. This is the first condition. Then else if count equal to max count, then we have to update only element, right? Max element equal to math dot mean of max element or nums of I, whatever is the minimum. Then we have to do one more thing. Else if count is greater than second max count, then in that case we will update two things. What is it? Second max count equal to count, and second max element equal to nums of I. Then again one more condition. Else if count equal to second max count, in that case we have to update only one thing. Second max element equal to math dot mean of second max element, comma nums of I, right? And this is where the for loop ends, and we have to return second max element, right? Let's try to run this. Okay, I equal to 0, and we forgot to give the semicolon. What is happening? Oh, sorry, I again gave it at the wrong place. Runtime error. Why runtime error? Let me just scan through the code what we did. So nums of length, so till now this is right. Then we have taken one for loop. Okay, I equal to 0. If visited of I, continue, right? In count we have taken the count, right? Count we have taken, it is correct. After the count, till now it is correct, right? J equal to 0, j is less than n, j plus plus, then nums of I, nums of j, and count plus plus, then visited of j true, right? Then we are closing this loop here. Till now it is correct. Array index out of bound, it is saying I don't think so. It should be array index out of bound, j equal to 0, j is less than n. I don't think so it is needed to do j equal to I. It is array index out of bound error. No, that is not needed. J should be 0 only. We are scanning through the entire. Okay, we have given I is less than n. Sorry, that was the error. Should be j, right? So yes, it is accepted now. So yes, we have completed our brute force approach. In the next lecture we'll try to do the more optimal approach for this. Thank you for watching.